Well, this sequence has cosine. And as you know, cosine looks something like this. It goes from negative, a positive 1, negative 1, positive 1, negative 1, positive 1, negative 1. So that, just by itself, the cosine diverges. It does not settle down to one answer. So if it was going to converge, then basically it could do whatever for a while, but then eventually it levels off. And whatever height it levels off at, if it's a height of 7, then it converges to 7. But if it jumps up and down between positive 1 and negative 1, that means it diverges. Also, if it goes to infinity, and however it does it, but it doesn't matter, but if it goes to infinity, that also is diverge. So this side is diverge, this side is converge. So for diverge, there's the two possibilities, either infinity, which could also be negative infinity, and you would still call that diverge, or if it bounces around between several different answers, that's also diverge. So what's happening with this? It has the cosine, which means it's going up and down. And about the only way I can think of to get cosine to not go up and down, so cosine itself would look like this, is if you take cosine and you divide by something, then that means the farther you go out, you're going to be dividing by bigger numbers. So the cosine would then start looking like this, and the divided by n would make it settle down. This has multiply by n squared, which is actually going to make it even jumpier instead of calm down. And so with this one, let's take a look at some numbers or calculator. And there it is. I was doing my homework right before you got here. So there's x squared cosine of x. And then if you start with, let's say 0 to 10, and then have y go from negative 10 to 10. So the function already takes off and it's off the screen. And then if you change the window, oh, there it goes. So look at that. I would have to change the window up until y is a 2000 to start seeing the graph. So the cosine part is making it go up and down, and then the x squared part is making it go way up and then way down. Sorry, it took me a moment with this touch screen, but then you could see the cosine part is making it go way down and then way up and then way down and then way up. So it seems that this one definitely diverges. So I'm wondering if we could use math to show that. So what's the limit as n goes to infinity for an n squared times cosine of n? Well, I can't use L'Hopital's rule because that is when you have division. This does not have division. And if I try to plug in infinity, this would be infinity squared, which I know is infinity. And then cosine of infinity, well, that just means it goes up and down, up and down, up and down. So you're basically taking infinity and applying that to the up and down, which is why we were seeing the graph go like this. So it's basically like the cosine function has been drinking too many Red Bulls or something, because it's jumping way off the screen. In order to show a little more math, what we could do is say, so what we could do is say that if you were to look at the absolute value, so you just concentrate on the positive values, what happens when it's positive? Then you could take the limit as n goes to infinity. That means you could take the absolute value of n squared, which when it's squared, it's already a positive number, so I don't really have to put the absolute value on that. And then times absolute value of cosine. And then the very biggest that cosine gets when it's an absolute value, the very biggest it gets is 1. So that means that you could say this is approximately like n, the limit, as n goes to infinity. And like I said, when you square something, it's positive, so I don't really have to put the absolute value on that one. And then if the cosine, the very biggest it gets is 1, you can just put a 1. And then this becomes infinity squared, because n squared, and infinity times infinity is equal to infinity. If you haven't seen the proof of infinity times infinity equals infinity, stay tuned. Someday we'll do that. Okay, so that's when it's positive. And then if you did the negative, it would go to negative infinity. And then that's why it was going like this, down to negative infinity, back up to positive infinity, down to negative infinity. So this one diverges.